I've got an application for law of sines here. I chose number 42 from our textbook. So we've got a plane up here in the air. And we're told that an observer on the ground has an angle of 41.2 degrees, an angle of elevation to look up and see the plane. But a second observer, who's standing 3,000 meters further away, has an angle of elevation of 35 degrees. Because the further away you are, the less steeply you have to look up in order to see that plane. So we're given this information here. What the question asks about is how high is the plane off the ground, and we're supposed to round to the nearest 100 meters. Now what I think is interesting about this is that the height of the plane off the ground is not in this triangle that I've drawn right here. Because if I'm trying to measure the height of the plane from the ground, I don't want the distance to this observer or the distance to that observer. I want the perpendicular distance. Whoops, that marker doesn't write. I want the perpendicular distance to the ground. So I'm going to be using law of sines in this triangle here, but then I'm going to need to use a right triangle. So I'm basically going to use law of sines to either get this side here or this side here. Which side I get will determine which right triangle I then use. If I found this side, I would use this right triangle, where this would be the hypotenuse of it. And if I found this side, I would use this right triangle, so that whatever side I find is going to be the hypotenuse of my right triangle. Okay. So there's a little bit of problem solving involved in just figuring out what I need to do. The other thing that I find interesting is that with this triangle that I've got in red here, 35 degrees is an angle in that triangle. 41.2 is not, because the angle that's actually in the triangle is the supplement of that. So I'm going to have to subtract 180 minus 41.2. This angle is actually 138.8 degrees. Now I've got these two angles, so I can find this one. That's what I'm going to need for my law of sines, because the one side length that I know is the 3,000 meters. Okay, so let's see. Let me just give this a name. I'm going to call that angle A, and I'm going to call this angle B and angle C. So let's go ahead and find B. Okay, doesn't matter. I could find either B or C. I'm going to find side B, but I need to find angle A first. So 138.8 degrees and 35.0 degrees. That's 173.8. So if I look at 180 minus 173.8, that's going to be 6.2 degrees. Okay. So here I subtracted from 180 because these two were supplementary. Just those two angles added up to 180. Here I subtracted from 180 because these 1, 2, 3 angles had to add up to 180. All right, excellent. So now I can go ahead and set up my, you know what? I'm going to actually change my mind, and I'm going to solve for side C instead. Simply because then I can use 35 degrees, which is a little bit less punching into my calculator than 138.8. It's very silly, but that's what I'm going to go with. Okay, so I can say sine of 6.2 degrees corresponds to 300 meters. In the same way, now if I'm finding C, that's opposite the 35 degrees. So in the same way that sine of 35 degrees corresponds to side C. So C times sine of 6.2 degrees is equal to 300 times sine of 35 degrees. C will equal 3,000, not 300. 3,000 sine of 35 degrees over sine of 6.2 degrees. All right, making sure we're in degree mode. 3,000 times sine of 35 degrees divided by sine of 6.2 degrees and I'm getting 15,932.77384 is what I see here. Okay. Now, I know I'm ultimately going to round my answer, but I don't want to round now and then use my rounded answer. Because every time I round, I introduce some error. And if I round and then use a rounded error in my calculations, the errors just get bigger and bigger and bigger. So I'm going to just keep that as is. I'm not going to round until my very last step. Okay. But now I can say, all right, so now I've got this nifty right triangle. Let me just copy that right triangle that we have. That's this right here. This is 41.2 degrees. I want to know this. This is, I'm going to label it as H, not for hypotenuse, but for height. That's how high the plane is flying. And what we just did is we figured out that C was this 15,932.77384. Okay, so now I've got a right triangle that I'm working with, and so I'm going to use some right triangle trigonometry. It looks like here I know the hypotenuse. I want to know the opposite side. So I'll be able to say sine of 41.2 degrees is equal to H over this lovely number, 15,932.77384. So the height is sine of 41.2 degrees times this lovely number, 15,932.77384. Now, I didn't really have to write all those digits every single time. I've still got that number on my calculator. So, while it's already there, I don't have to punch in the digits again. I'm just going to hit times sine of 41.2 degrees. And I get 10494 point blah, blah, blah. But we're rounding to the nearest 100 meters. Okay, so that's to this place right here. That's a 9, so we'll round up. So we would say approximately 10,500 meters. Excellent. Okay. So I really think it's crucial that you have the picture. Sometimes what you're asked to solve will be a side in the triangle that you're working for. But sometimes, like so, you're going to have that one of the sides in this triangle becomes a side in a right triangle where you're looking for, in this case, just a vertical distance that's part of that right triangle. All right, fun stuff.